Let us solve the equation x plus 2 to the power 4 plus x plus 1 to the power 4 equal to 17. So we write the equation once again. X plus 2 to the power 4 plus x plus 1 to the power 4 equal to 17. Let's write this one as equation 1. Clearly we see that x equal to 0 and x equal to minus 3 are the solution of the given equation. So we observe that when I take x equal to 0, 2 to the power 4 plus 1 to the power 4 is 17. And when I take x equal to minus 3, again minus 3 plus 2 is minus 1 to the power 4, and minus 3 plus 1 is minus 2 to the power 4 equal to 17. Therefore, x equal to 0 and x equal to minus 3 are the solution of the given equation. So we have two pair of solution, x equal to 0 and x equal to minus 3. So obviously x is a factor of this, say, the polynomial. If I take everything equal to 0, and okay, x plus 3 will also be a factor of the polynomial if I take everything equal to 0. That means both x and x plus 3 are factor of x plus 2 to the power 4 plus x plus 1 to the power 4 minus 17. Okay, might be we can divide this expression by x and x plus 3 and maybe we will be able to solve it, but we'll follow a different method. We observe that if I add 2 and 1, I'll get 3, and average of 2 and 1 is just 3 by 2 or 1.5. So what we do is let x plus 3 by 2 equal to y. This has an advantage that x plus 1 equal to y minus half and x plus 2 equal to y plus half. So we can write equation 1 is x plus 2 is y plus half. So y plus half to the power 4 plus x plus 1 is y minus half. Y minus half to the power 4 equal to 17. We copy as it is. Now what's the advantage of this? The advantage is that when we expand and cancel it out, the odd powers will vanish, so we'll get a biquadratic equation. Let's do it. Let's write this as y plus half whole thing square whole thing square. The same here, y minus half whole thing square, again whole thing square. Remember, powers of power we can multiply it, so 2 into 2 is 4, 2 into 2 is 4. Now we know the formula of that a plus b whole thing is square, that's equal to a square plus 2 into a into b plus b square. 1 by 2 square is 1 by 4. The same thing here, a square minus 2 into a into b plus 1 by 4. Whole thing square equal to 17. If you know binomial theorem, you could have done directly. You could have moved directly up to this step, but we are doing it assuming that we do not know binomial theorem. So we can cancel 2. We can cancel 2. Now we have an expression a plus b plus c whole thing square. That's equal to a square, so y to the power 4 plus b square, so y square plus 1 by 4 square is 1 by 16 plus 2ab, 2 into y square into y plus 2bc, y into 1 by 4 plus 2ca, 2 into 1 by 4 into y square. The same we do it for this one, a minus b plus c whole thing square, or rather we'll assume b to be negative, so a plus b plus c whole thing square, that's equal to a square plus b square minus y whole thing square is plus y square plus c square 1 by 16 minus 2 into y square into y minus 2 into y into 1 by 4 plus 2 into 1 by 4 into y square equal to 17. We copy as it is. Now as we said earlier, the odd powers will get cancelled, and yes, it's getting cancelled. Odd powers simply getting cancelled. Okay, next y to the power 4 plus y to the power 4, that's 2y to the power 4 plus y square 2y square, And this one is half y square, right? Yes, 2 into 2 is 4. So half y square. Half y square plus half square y square is 1 number of y square. So we have 3 number of y square. And then 1 by 16 plus 1 by 16 is 2 by 16. That's 1 by 8. Let's write plus 17 to the left hand side. So minus 17 equal to 0. So as we said earlier, we'll get a biquadratic equation that is easy to solve. 8 into 17 is, let's do rough work, 17 into 8, 8 into 7 is 56, 8 into 1 is 8, 136. And if you subtract 1, you will get minus 135 by 8 equal to 0. Now, if you know how to factorize it, well and do. We might be able to do it even by splitting the middle term, but we'll apply quadratic equation formula. If we have a y square plus by plus c equal to 0, then roots are given by, but here we have, instead of y, we have y square. So y square equal to minus b. So minus 3 plus minus root over b square. So my plus 3 whole thing square minus 4 into a is 2 into c. C is minus 135 by 8. Divided by 2a, that's 2 into 2. Oh, 8 is getting cancelled. Minus 3 plus minus 9 plus 135. 9 plus 135 is 144. And square root of 144 is just 12 by 4. If I take plus sign, then 12 minus 3 is 9. So this is 9 by 4. If I take minus sign, minus 3 minus 12 is minus 15 by 4. Now we got y square equal to 9 by 4. So y equal to, simply we have to take the root. When we take root, plus minus 3 by 2. So those are the real cases. But we tend to get 4 number of roots because this is a polynomial in degree 4. So we are likely to get 4 number of roots. So 2 of them will turn out to be real and 2 of them will turn out to be complex. So square root of minus 15 is root 15 into I, and square root of 4 is just 2. But initially we have assumed that y equal to x plus 3 by 2. Y equal to x plus 3 by 2. So we replace y by x plus 3 by 2. So we obtain x plus 3 by 2 equal to plus minus 3 by 2 comma root 15 by 2 times I. That gives us x equal to, when I take plus 3 by 2, 0. When I take minus 3 by 2, minus 3 by 2, and minus 3 by 2, that's minus 3. Plus minus root 15. I forgot plus minus because we are taking root, so we'll get plus minus, of course. And then minus 3 by 2 plus root 15, root 15 I by 2, comma minus 3 by 2 minus root 15 I by 2. So we have 2 real roots, 0 comma minus 3. These are real roots. And 2 complex roots is given, minus 3 by 2 plus root 15 I by 2 and minus 3 by 2 minus root 15 I by 2. And we are done.